So in 8.5, talking about adding and subtracting rational expressions. And what we're going to see throughout this section is that although these look really scary and a little bit overwhelming, they're not. Um, Everything we do here is going to come right back to everything we learned in elementary school when we learned how to add fractions together. So kind of just as a refresher in what it means to add fractions, right? If I look at my first example here, 1/2 plus 1/4, well, I can't add these yet because my denominators are not equal, but I can make them equal because their least common multiple is 4, right? So I'm going to put these both over 4, and I'm going to think to myself, what did I do to 2 to get to 4? Well, I multiplied by 2, right? To get from 2 to 4, I multiplied by 2. So to get from 1 to whatever goes in the numerator, I multiply by 2. I didn't change 4, so I'm not going to change the second one. I'm going to add these together and get 3/4. Same principle over here, right? I want to find my least common multiple. My least common multiple, well, in this case, is just the product, right? My least common multiple is 20. So I want to turn these both into fractions over 20. So what do I do to 5 to get to 20? I multiply by 4. So to get from 2 to my new fraction, I'm going to multiply by 4. Likewise, how do I get from 4 to 20? I multiply by 5, so I'm going to multiply 3 by 5 to get to 15. So I can add these together and get 23 over 20. This same process applies when I look at truly rational expressions, right? Things that have variables, fractions that have variables in them, essentially. So I want to figure out what my common denominator is. The only difference here is I'm going to write this a little bit differently than I did before. I'm going to go straight to writing this as one big long fraction. And I want to know, what is my least common multiple? Well, let's take this in pieces. I notice that I already have an x in common, which is nice, so my least common multiple is going to involve x in some way, just on its own. And then my 3 and 2, right? So 3 and 2, the least common multiple of 3 and 2 is 6. So my least common multiple of 3x and 2x, for all intents and purposes here, is 6x. So I'm going to think to myself, just like I did with the fractions, what do I need to do to 2, or sorry, what did I do to 3x to get to 6x? Well, I just multiplied by 2, right? So I'll do this in a different color. To get from 3x to 6x, I just multiplied by 2. So I'm going to do the same to my numerator. Just going to multiply by 2. Actually, I'm going to write it this way, just to show you what's really going on here. And then likewise, what did I do to 2x? To get to 6x, I multiplied by 3. So to get from x plus 1 to my new numerator, I'm going to do the same thing and multiply by 3, right? So to simplify this a little bit, I get 4 plus 3x plus 3 over 6x. I get 7 plus 3x over 6x. So the process is the same. Now the question turns into, well, what do we do when I have nothing really in common at all? So if we look here, right, I have an x plus 1 and an x squared plus 1. Well, there are no common factors here, really. So what do? Well, I do the same thing that I did kind of up here, right? There's nothing in common, so I just took my least common multiple by multiplying them together. And in this case, that's what I'm going to do here as well. All right, so I'm going to write this as kind of saying, if you're ever stuck, just multiply the denominators together. If you can find a simpler way, I would just do that. Obviously make this easier on yourself if possible. But if you're ever stuck, you can always get out of it by multiplying the denominators together as your common denominator. So I'm going to think, what do I do with 3x, or sorry, before I do that, what do I do with x plus 1 to get to my common denominator? What did I do? Well, I took x plus 1 and I multiplied by x squared plus 1. So whatever I do to that half of the fraction, I need to also do to the numerator as well. I'm going to think the same thing here. What did I do to x squared plus 1 to get to my common denominator? Well, I multiplied by x plus 1. And of course the operation in the middle is addition, so that's going to stay. Now we've got some work to do, so let's start foiling things out, distributing whatever we need to do here. So, oh sorry, that should be a 5x minus 1 on the top. So I'm going to get, let's see, 3x squared plus 3x. And then we're just going to FOIL and we'll simplify it later. So I have 5x squared minus x plus 5x minus 1. And then at the denominator, I've got x cubed plus x squared plus x, x cubed plus x squared plus x plus 1. Yeah, second guess myself for a minute. So just one final step here. Let me just combine like terms. 8x squared. 3 minus 1 is 2, plus 5 is 7. Minus 1 over x cubed plus x squared plus x plus 1. Technically, yes, I could factor my numerator because there are my numerator because there are factors of 8 that add up to 7 with opposite signs, right? It'd be 8 and negative 1. But there's really no reason to, because I know that nothing down here is going to cancel out with anything in my numerator, so there's no reason. If I had a reason to believe I could simplify this somehow, then sure, I would absolutely try to factor. So this process is going to be the same even with subtraction, right? If I think back again to just fractions, I'm going to make a common denominator first. So actually, just to show the connection, I'll write it out the way that I have been. My common denominator, well, there's really nothing clear, so when in doubt, multiply together, right? 3 times 2 is 6. What did I do to 3 to get to 6? What did I do to 3 to get to 6? I multiplied by 2. So I'm going to do the same thing to my numerator. Actually, let me keep my color scheme kind of the same here. So this. And then what did I do to 2 to get to 6? I multiplied by 3. So likewise, I need to do that to that numerator. The operation in the middle is its subtraction now, so that's going to carry over. So I have 4 minus 3 over 6. I get 1/6. The same thing happens here with a rational expression. So let's look at my common denominator. Well, fortunately, I've already got these x's in common, right? So my common denominator needs to involve that x somehow. And then the least common denominator of 3 and 2 is 6. So I need to look again, right? What do I do to 3x to get to 6x? How do I get from 3x to 6x? Well, I'm going to multiply by 2. So I'm going to do the same thing in my numerator, 2 times 2. Now I'm going to look at my second term and say, what do I do to 2x to get to 6x? Well, I multiply by 3, so I'm going to do the same thing there, 3 times x plus 1. Operation in the middle is subtraction, so that's going to carry down. We're going to simplify. I'm going to get 4 minus 3x minus 3. So the one thing you need to be careful of in subtraction is you need to watch out for the negative. You need to be really careful about the distribution of your negative, just like I did here and there. your answer is just going to be wrong. If you don't, there's no other way around it. You have to really be careful with that negative. So simplifying here, I'm left with 1 minus 3x over 6x. So if I take a look at a couple bigger problems, and this first one on the left, same process, right? My common denominator, well, nothing immediately in common, so let me multiply. We'll just multiply together, 5 times x plus 1. So again, I'm going to look at this. I'm going to say, what do I need to do to x plus 1 to get to 5 times x plus 1? Well, I just multiply by 5, so I'm going to multiply by 5 in my numerator. Likewise, again, what do I do to 5 to get to 5 times x plus 1? It's multiplied by x plus 1. I realize these multiplication x's are starting to get a little bit confusing, so let me switch to the dots real quick. So we're going to multiply by x plus 1 times 3x. Operation is subtraction, so that's going to come down. Let's simplify some things. I have 30x squared minus 3x squared minus 3x, being really careful with that negative, for 5x plus 1. Can I simplify this at all? Well, let's find out. I can take a 3x out of the top, right? So I'm left with a 10x. No. Hold on. I can combine this. I get 27x squared minus 3x over 5 times x plus 1. Let's just see if this simplifies. There's a 3x in common in the numerator. I'm left with 9x minus 1. Right, so there's nothing in common. This is kind of our simplest terms, or just fully reduced. I've checked to see if there's anything I can factor. Obviously there's nothing, so we're good to go. This one over here on the right, your first thought might be, well, there's nothing immediately in common, so I'm just going to multiply these together. But this could get really messy if I do, right? Because I've got some higher powers here. So let's take a look at this second denominator really quick, and see if it can factor into anything. Well, factors of 6 that add up to 5, of course, this tells us that the signs are the same. So yes, this is going to be x plus 2, x plus 3. So let's rewrite our equation here. This is x plus 1 over x plus 3 minus 2x minus 3 x plus 2 times x plus 3. Well, so now we can see that there is a common denominator, right? There's a common x minus x plus 3 here. So my common denominator, well, it's going to be more than the x plus 3, but be x plus 2 times x plus 3. And I'm going to look at this just like we did before, right? At this point now, everything is the same as something we've done before. So what do I do to x plus 3 to get to my common denominator? I multiply by x plus 2. X plus 1 sticks around. Minus, what do I do to the common, to my second denominator to get to my common denominator? Nothing. They are the same. So nothing is going to happen here. 2x minus 3. So let's simplify. I'm going to have x squared plus 3x plus 2 minus 2x plus 3 over x squared minus 5x plus 6. Combine like terms, I have x squared plus x plus 5 over x squared plus 5x plus 6, and I know that this is not going to reduce, nothing's going to factor, right? This is not reducible, so this is my final answer. So that's adding and subtracting. But there's one more thing that this section talks about that is important too, and that's the concept of what we call complex fractions. Your first thought might be fractions are already complex enough. Why do we need to make them harder? It's not. It's just another way of writing them. This is just harder looking division. It's only division. Right? This is saying 2/3 divided by 4/5, which means we could write this as 2/3 divided by 4/5. Well, now it's just a division problem, and we know to do that. Keep, change, flip, 10/12, which reduces to 5/6. Same idea with a rational expression, right? This is just a fancy way of writing division of fractions. So if we multiply these together, we're going to keep, change, flip, and multiply across. Well, before I do that, this, by the way, I know, factors, I want a darker color here, into x plus 1 squared. So I have x plus 1 cubed over 12x. Right, so all this is a scarier looking way of writing division of fractions. You might be wondering, why would they ever do that? Sometimes it is useful when you're kind of setting up a problem, but it's always more useful right after you do that to then rewrite it as division, flip, and multiply and all that. Let's look at one more, and your first reaction is, wow, this looks awful. The trick to make this as easy as possible is to break it into smaller pieces. Always. You can always break a problem up into smaller pieces. I've already got my numerator as one term, right? Numerator, one term. Awesome. My denominator is not. My denominator is in two terms. Let's see if we can condense this a little bit, make it a little bit easier to work with. Well, we've learned how to add fractions, right? Let's find our common denominator. It's going to be x times x plus 4. What do I do to x plus 4 to get to my common denominator? I just multiply by x, right? So 1 times x is x. And then what do I do to x to get to x plus 4? Looking at my second term. Right, so I'm looking at my second term here. Well, to get to this, from there, I multiply by x plus 4. So this is 2 times x plus 4. Operation in the middle is addition. So up top, I get 2 plus 2x plus 8. I'm actually going to leave my denominator alone here because I know that there's going to be more to do with it. So I want to try to leave this as factored as I can, just so canceling things out later might be easier. It might make my life easier later on. Let's finish simplifying up in the numerator, right? So I have 3x plus 8 over x times x plus 4. Well, great. So we actually can reduce this. We can simplify it, make it easier to work with. So if I go to rewrite my equation using what we've come up with, I have 5 over x plus 4 divided by 3x plus 8 over x times x plus 4. Well, now this is just division, right? We just learned how to deal with this. Right? All this is 5 over x plus 4 divided by 3x plus 8 over x times x plus 4, which we know, keep, change, flip. We know that we can just turn division into multiplication, and our process just gets that much easier. I see but I have 2x plus 4s on opposite sides of the fraction, so I can cancel them out. There we go. Keep my colors the same. And now I can multiply across. So I have 5x over 3x plus 8. And this really terrifying looking problem doesn't turn out to be so bad after all.